Here's example 2 of solving trig equations. So here we have sine of theta equals 0.34, so a number that's not so nice, not directly related to the unit circle. So part A, solve in the interval 0 to 2 pi. And again, all that means is just 0 is less than or equal to theta is strictly less than 2 pi. And then part B, find the general solutions. Okay, so let's go ahead and start this kind of the same way we did in example 1. Actually, what we want to do first really is draw a unit circle. So even though 0.34 is not really a nice number or a nice value that relates to the unit circle, we still want to draw a unit circle so that we can use the symmetry properties of the unit circle, which we sort of implicitly used last time, but we didn't really need to talk about it because in example 1 we had nice numbers that were on the unit circle, so we could just use those special angles and special values there. Okay. Okay, so sine of theta is 0.34. Now the thing we want to keep in mind is that remember, if the sine function is positive, then we're somewhere in quadrant 1 or quadrant 2. So more specifically, if sine of theta is 0.34, then the terminal side of theta hits the unit circle somewhere up here in quadrant 1 or quadrant 2. So let's go ahead and draw that. So that'll be somewhere maybe over here. We don't have to get the exact location correct, just the quadrant. And what we also want to make sure that we do correctly is use these symmetry properties here. So kind of a bad picture already, but anyway, this is going to be theta 1. We're going to call that theta sub 1. Okay, theta with a little 1 subscript. And then here is theta sub 2, theta with a little 2 subscript. Okay, so what are we talking about, these symmetry properties? Well, here and here, these 2 points have the same y-coordinate. Okay, so remember, if you have an angle theta that's in standard position, the terminal side of angle theta hits the unit circle at some point. Okay, and the y-coordinate of that point is the sine of the angle. Okay, so the sine of theta sub 1 is 0.34, and the sine of theta sub 2 is 0.34, and that's the y-coordinates of these 2 points here. Okay, okay. Now what we can do then, just sort of like in example 1, to get this first one here, we can just take the inverse sine. Because remember, if you take the inverse sine of something positive, in this case positive 0.34, you're going to be in quadrant 1. So that's going to give us this one that we want. So we're going to say theta sub 1 equals the inverse sine of 0.34. Okay? And we'll toss that into a calculator a little bit later. But for now, okay, just know that we have to do that to get this one here. Okay? Now, what about theta sub 2? How are we going to get theta sub 2? So in example 1, we could just use the unit circle to get the other one. But here, we can't really use special values on the unit circle, but we can use symmetry properties. So let's go ahead and do that. So how do these symmetry properties help us? Well, let's go ahead and zoom in here. This angle right here and this angle right here have to be exactly the same size. That's what the symmetry property tells us. So here, and what is this angle here? It's theta sub 1. Okay. Okay, so this angle right here, theta sub 1, it's just the same thing as this one right here. So this one right here must also be theta sub 1. Okay, why is that? It's because this point here and this point here have the same y-coordinate. Okay, therefore this angle and this angle must be the same. Okay, it's because these 2 points have the same y-coordinate, roughly speaking. They have exactly the same y-coordinate, and that's roughly the reason why this angle here and this angle here have to be exactly the same. Okay, so how does that help us knowing that this is theta 1? Well, notice, let's start here at this angle 0, okay, and then go here, theta sub 2. Okay, if we go theta sub 2, that's going to bring us here, theta sub 2. So theta sub 2 plus, now if we keep going, this angle right here, what's this angle? It's theta sub 1. It doesn't matter where we draw it, whether we draw it over here or over here, it's the same exact angle. Theta sub 1 equals what? Well, if we go all the way around, that's pi, right? We go, or halfway around the circle, really. So theta sub 2 plus theta sub 1 is going to bring us right here. And if we're right here, that's an angle of pi units, or pi radians, rather. Okay. So theta sub 2 plus theta sub 1 equals pi. So that's how the symmetry property helps us. So knowing that this angle right here is theta sub 1 tells us, okay, if we go theta sub 2 and then theta sub 1, that's going to put us at pi. Okay. So that's how we get theta sub 2. Theta sub 2 equals pi minus theta sub 1. Okay. And we know theta sub 1 is the inverse sine of 0.34. So theta sub 2 is pi minus the inverse sine of 0.34. Okay, now we can start tossing these into calculators. So let's go ahead and bring out our calculator. So we'll zoom in here. Now we want to make sure that we're in the radian mode unless otherwise specified. So this RAD right here tells us that we're in the radian mode. And we want to make sure that we do the inverse sign. Okay, we've got to have that -1 there. Do the inverse sign, not just the plain old sine. Be careful about that. So we want to do the inverse sine of 0.34. And then we also wanted to do pi minus that. Okay, so our answers for part A are about 0.3469 and about 2.7947, we'll say. Okay. So the answers are for part A, theta is approximately equal to 0.3469, or theta is approximately equal to 2.7947. Okay, those are the answers for part A. Now what about part B? Well, just like in the previous example, all we have to do is do the plus 2k pi thing. So remember, you can be at this angle θ1, or you could add 2 pi as many times as you want, or you can subtract 2 pi as many times as you want, and then you'll end up at the same terminal side here, which means the same value of the sine function, which means this equation is still solved. So for part B then, the answers are theta is approximately equal to, approximate because these are approximate values, remember. So 0.3469 plus 2k pi, where k is any integer, abbreviate int for short, I'm out of space kind of, or theta is approximately equal to 2.7947 plus 2k pi, where k is any integer. And this k just represents how many times you go around the unit circle. So if k is 1, that's just 2 pi. If k is 2, it's 2 times pi, which is 4 pi. So if k is 1, go around once. If k is 2, go around twice. Okay? But if k is -1, then this becomes 0.3469 minus 2 pi, and that means we go in the negative direction once. Okay? If k is -2, go in the negative direction, the clockwise direction twice, okay? And so on and so forth. Same exact thing with the theta sub 2. Okay, plus 2 pi, so if k is 1, then we go like this. Okay? If k is 2, then we go around twice. If k is -1, go in the clockwise direction once, and so on and so forth. Okay, so this is the answer to part B. So notice just the answer for part B is just the answer for part A with the plus 2k pi on it, just like in example 1. Okay, so that's it for example 2 of solving trig equations.